Hello students. Hello and welcome to this video on mathematical induction. In this video, we will solve question number 71 to 80. The link to download the PDF will be in description, as well as at the end, I'll show you how you can maintain an updated copy of the book. Also, I'll show you how you can ask questions to me on my question and answer website, which I have developed for you guys. So without further ado, let's get started. There are some more divisibility questions, so we go through them fast. So question 71, our expression is n cube plus 3n square plus 5n plus 3, and the condition for divisibility is by 3. So we let p of n is equal to given expression, substitute n is equal to 1, we get 12, which is divisible by 3. So the statement is true for n is equal to 1, we let it be true for n is equal to m. So we have got m cube plus 3m square plus 5m plus 3 is equal to 3k, where k is in the set of natural numbers. Next, we substitute n is equal to m plus 1. We get m plus 1 cube plus 3 times m plus 1 squared plus 5 times m plus 1 plus 3, which upon expansion is equal to 3k plus 3m square plus 9m plus 6, which is divisible by 3, and hence by induction we have the result. Question 72 says that the expression is n plus 1 times n plus 2 times n plus 3 times n plus 4 times n plus 5 is divisible by 120. So we substitute n is equal to 1, we get 720, which is divisible by 120. So the statement is true for n is equal to 1. We let it be true for n is equal to m. So we have got m plus 1 times m plus 2 times m plus 3 times m plus 4 times m plus 5, that is 120k, where k is in the set of natural numbers. Now we subtract pm plus 1 minus pm. We get 5 times m plus 2 times m plus 3 times m plus 4 times m plus 5. Now these are 4 consecutive numbers, therefore they have at least have to be one multiple of 2, 3 and 4 each. So 2, 3, 4 when multiplied gives us 24, and this 5 gives us 120. And thus by induction we have the result. Question 73, the expression is n raised to the power 5 minus n, and the divisibility is by 5. So we put n is equal to 1, we get 0, which is divisible by 5. We let it be true for n is equal to m, that is n raised to the power 5 minus m is equal to 5k. Now we put n is equal to m plus 1, we get m plus 1 whole to the power 5 minus m plus 1. So we get m to the power 5 minus m plus, this should be 5c1 m to the power 4. There is typing mistake here. Then we have 5c2 m cube plus 5c3 m square plus 5c4 m. And then there would be 1 which is cancelled with the 1 of this one, which is divisible by 5, and hence by induction we have the result. So how this is divisible by 5 is, this is 5k from this relationship, and all these will contain a factor of 5. Okay? So that you need to look at permutation combination. And this expansion has come from the binomial theorem. Question 74 says that our expression is 1 plus x raised to the power n minus 10x minus 1 is divisible by x square, where x is not equal to 0. So we let Pn is equal to given expression, substitute n is equal to 1, we get 0, which is divisible by x square. Now we put n is equal to m, we get 1 plus x raised to the power m minus mx minus 1 is equal to q of x into x square, where qx is a polynomial in x. Next we substitute n is equal to n plus 1, we get 1 plus x raised to the power n plus 1 minus n plus 1 times x minus 1. We take 1 plus x common from out from this first one, we get 1 plus x times 1 plus x raised to the power m minus mx minus x minus 1. So this is equal to qx into x square plus x times 1 plus x raised to the power m minus x. Now we expand this 1 plus x raised to the power m and we take x common, we get MC0 plus MC1x, MC1x, and so on up to MCM x raised to the power n minus x, which is divisible by x square because x will cancel this MC0. Okay, MC0 is 1, so this will get cancelled, and then x will be multiplied by this, so power should be square and more. Question 75 says that show that n times n square minus 1 is divisible by 24, where n is in the set of odd positive integers. So we let Pn is equal to n times n square minus 1, P of 1 is equal to 0, which is divisible by 24, so the statement is true for n is equal to 1. Now we let it be true for n is equal to m, where m is equal to 2k plus 1 for all k in natural numbers. So Pm becomes 2k plus 1 times 4k square plus 4k, and we evaluate it to be 4k times 2k square plus 3k plus 1 is equal to 24s, whereas in the set of natural numbers. Then we put m is equal to m plus 2, we get 2k plus 3 times 4k square plus 12k plus 8, which we evaluate to be 24s plus 24k square plus 48k plus 24, which is divisible by 24, and hence by induction we have the result. Question 76 says that show that n times n square plus 20 is divisible by 48, where n is in the set of even positive integers. We let n is equal to n times n square plus 20. We put n is equal to 2, we get 48, and which is divisible by 48. If you argue that 0 is odd even number, then putting 0 will also make it 0, which will be divisible by 48. Then we put n is equal to 2m, we get 8m times m square plus 5. We take 4 out of this, okay? We get 48s, which is, we let it to be 48s, whereas in the set of natural numbers. Now we put n is equal to m plus 2m plus 2. We evaluate it to be 48s plus 24m square plus 24m plus 48. Now this we take m square plus m, and now we are going to prove Qn is equal to m square plus n is divisible by 2. So obviously it is divisible by 2. You can prove that by induction or by the simple observation that product of two consecutive integers is always divisible by 2. And thus by induction we have the result. Question 77 says that show that 2 raised to the power 2n plus 1 or 2 raised to the power 2n minus 1 is divisible by 5, according as n is odd or even positive integer. So we let P of n is equal to 2 raised to the power 2n plus 1 and Qn is equal to 2 raised to the power 2n minus 1. Now P of 1 is 2 square plus 1, that is 5, and P of 2 is 2 raised to the power 4 minus 1 is equal to 15. Both are divisible by 5, so they are true for n is equal to 1 and 2. Let the statements be true for n is equal to 2m and 2m plus 1. So we have got for 2m plus 1, 2 raised to the power 4m plus 2 plus 1 is equal to 5k. And Q of 2m is equal to 2 raised to the power 4m minus 1 is equal to 5l, where L and M are in the set of positive natural numbers. Then we put n is equal to 2m plus 3, we get 15 times 2 raised to the power 4m plus 2 plus 5k, which is divisible by 5. And we put n is equal to 2m plus 2, we get q of 2m plus 2 is equal to 2 raised to the power 4m plus 4 minus 1, which is equal to 15 times 2 raised to the power 4m plus 5l, which is also divisible by 5, and hence by induction we have the result. Question 78 says that prove that 5 raised to the power 2n plus 1 is divisible by 13 if n is odd. Hence deduce that 5 raised to the power 99 leaves the remainder 8 when divided by 13. So we let Pn is equal to 5 raised to the power 2n plus 1. We put n is equal to 1. We get P of 1 as 26, which is divisible by 13. So the statement is true for n is equal to 1. We let it be true for n is equal to 2n plus 1. We get P of 2n plus 1 is equal to 5 raised to the power 4m plus 2 plus 1 is equal to 13k, where k is in the set of natural numbers. Now we put n is equal to 2m plus 3. We get 624 times 5 raised to the power 4m plus 2 plus 13k. Now this is divisible by 13. 13 4 they are 52. So 104 will remain, and 13 8 they are 104. So this is 48 times, okay? So this is divisible by 13, hence by induction we have the result. Now 5 to the power 99 is equal to 5 times 5 to the power 98, which is equal to 5 times 5 raised to the power 2 times 49. Now this we can write as 5 raised to the power 5 to the power 98 plus 1 minus 5. So we add and subtract 5. So this will leave a remainder 8 when divided by 13. Question 79 says that show that 4 times 6 to the power n plus 5 raised to the power n plus 1 leaves remainder 9 when divided by 20. So we let the given expression as P of n, we put n is equal to 1, we got 49, which leaves remainder 9 when divided by 20. So the statement is true for n is equal to 1, we now put n is equal to m. So the expression is 4 times 6 to the power m plus 5 to the power m plus 1 is equal to 20k plus 9. This we have left to be true. But k is in the set of natural numbers. Now we put n is equal to n plus 1. We get 26 times 6 raised to the power m plus 5 times 5 raised to the power m plus 1, which is equal to 4 times 6 to the power m plus 5 times 20k plus 45. Now we will prove that this leaves a remainder 9 when divided by 20. So we let q of n is equal to 4 times 6 to the power n plus 45. Q of 1 is 49, which leaves a remainder 9 when divided by 20. Now we put n is equal to r. Okay, there is something wrong here. This m should be r, or we put here n is equal to m again. Doesn't matter. So we got 4 times 6 to the power m plus 45 is equal to 20s plus 9. And q of r plus 1 is equal, this should be n plus 1. 4 times 6 raised to the power m plus 1 plus 45, which is equal to 20 times 6 to the power m plus 20s plus 9, which leaves a remainder 9 when divided by 20, and hence by induction we have the result. Question 80 says that show that for n in set of natural numbers 3 to the power n plus 8 to the power n is not divisible by 8. So let Pn is equal to 3 raised to the power n plus 8 raised to the power n. P of 1 is 3 plus 8 is equal to 11, which is not divisible by 8. Now, the observation we can say that 3 to the power n will be odd and 8 to the power n will be even, so sum would be odd, which will not be divisible by 8. So let it be true for n is equal to m. So we have 3 to the power m plus 8 to the power n is equal to 8k plus s, where s is such that s in the set 1, 2, 3 to 7. Now P of m plus 1 is equal to 3 times 3 to the power m plus 8 times 8 to the power m is equal to 8k plus s plus 5 dot 8 to the power m, which will leave a remainder s when divided by 8. Hence by induction we have the result. Okay. So with this, we come to the end of 8 set of problems on mathematical induction. Now I'll show you the website. So this is my website. You can download algebra, trigonometry, and coordinate geometry from second, third, and fourth link. Note that the PDF when you download will not have the date. So you need to add date, and after 15 or 13 days, you should come and revisit this page to see if it has been updated. And I can't put date in the link because the date keeps changing and old links will become invalid, which might be shared by other people. And if you want to ask me questions, you can come to my website, timnika.astrolock.org, make a login here and ask questions. You can use mathematical formulas here. So you can ask questions on algebra, calculus, coordinate geometry, probability, and trigonometry, the standard class 12 stuff. So this supports math. You need to know how to type MathJax or LaTeX formulas, because YouTube is not much suitable for mathematical content. And with this, we come to the end of this video. And in the next video, we will solve 10 more questions. I hope that you have found this video useful. So thanks a lot for watching the video. I'll see you in the next one tomorrow. So have a great day and enjoy.